Today we're going to talk about the unit circle. Okay. Again, this is kind of some good trig stuff. What? Alyssa loved it, I'm sure. The unit circle, though, section 13.3. Again, as Maddie said, yes, trig deals with this a lot. That's kind of what she's referencing. So if you go plan on taking trig next year, or something along those lines, you'll do a lot of this. If you go take calculus later on, you do a lot more on this.
I sat in on our class for like the first 5 minutes, and I heard her screaming unit circle like 4 times.
So, hey, this is what we're talking about. Unit circle is what we're talking about here. So, hey, know if you learn it now, it's just that much easier next year. Okay? But section 13.3, talking about the unit circle here. Okay? First thing we're going to talk about is radians. Radians are a real number measure of rotation. Now think about the other day we were talking about SOHCAHTOA using our calculator to find sine, cosine, tangent functions. And one of the things I said, make sure that your calculators were in degree mode. If you look at your calculators, the other mode that you have is radian mode. Okay, so there is 2 modes for your calculator. There is radian and degree mode. Radians are just another form to kind of talk about the rotation. Okay, to convert between radians and degrees, use the following identity. Pi radians equals 180 degrees. So you're like, what does that even mean? Okay, here's what you gotta know. To convert between degrees and radians, solve the identity for 1 degree. So to convert from degrees to radians, you're going to multiply by pi over 180. Okay, so to convert from radians or from degrees to radians, you multiply by pi over 180. So pi radians out of 180 degrees. To convert from radians to degrees, you're going to multiply by 180 over pi radians. And I'll show you why that is here in a second. Okay, so to convert 60 degrees to radians, I'm going to take 60 times pi over 180. And I simplify. Well, 60 over 180 is basically going to simplify to what? Like my zeros cancel. 6 goes into 18 what? 3. So I get pi over 3. That is in radian form. Again, why is that? My degrees cancel out, giving me whatever I get, pi radians. To go the other way now. Let's say I have 5 pi over 4 radians to degrees. Well, I'm going to take 5 pi over 4. Oops. And I'm going to multiply by 180 over pi. And what do I multiply over pi? Because, well, my pi's canceling. And I get, now I can simplify, 4 goes into 180, I believe it's 45 times. 5 times 45 gets me 225. I get 225 degrees. Here's kind of what you need to know. Radians has pi in it. Degrees, no pi. No pi. Okay? So degrees, again, you've known degrees, right? We've done degrees probably since like 5th grade. You've talked about angles and degrees. That's not the new. So think about your typical degree angles. Radians is the new one. Radians is always going to be in terms of pi. Typically, not always, typically you're always going to have like a fraction. Okay, radians is a fraction represented with pi. Okay, so pi over 3. That's kind of really the 2 things you kind of got to recognize today. All right? So let's look at number 1 here. Negative 45. I want to convert each measure from degrees to radians. So it's negative 45 degrees, and I want to convert that to radians. So I'm going to take that times pi over 180. So I get negative 45 times pi over 180. Now again, basically, some people like to multiply then simplify. You can cross multiply or cross simplify. It does not matter. How many times is 45 going to 180 though? 4 times, right? So I'm going to get negative pi over 4. That's in radian mode right there. And all we did was simplify. Number 2, 150 degrees, 2 radians. So that's like 150 times pi over 180. And I simplify. My zeros can cancel out. I get 15 over 18. 15 over 18 simplifies to. So I get 5 pi over 6. Again, what's the difference here? Radians is in terms of pi. Radians always have pi. Number 3, 210 degrees. I'm going to take that to radians. So I'm going to multiply it by pi over 180. What can cancel off to simplify this? I can cross off a 0. So I get 21 over 18. 21 over 18 simplifies to. So I get 7 pi over 6. What do you notice about this? Where's my pi always associated at? Pi is always in the numerator. There you go. Number 4, negative 120 degrees. Well, I'm going to take that times pi over 180. What can cancel off? My zeros. So I'm left with negative 12 over 18, which simplifies to negative 2 pi over 3. And that is in radian mode right there. So a little different. Okay, number 5. Convert each measure from radians to degrees. Now I'm going to go the other way. Okay, so basically, to go to radians, you're going to divide by 180. Basically, you're divide by 180 and tack on pi. To go to degrees, now I'm going to multiply by 180. And why am I multiplying? Again, my pi's cancel out. Okay, radians cancel out. You're good there. Now I just need to cross cancel or simplify here. How many times does 3 go into 180? 60. So I'm left with 4 times 60. 4 times 60 is how many? That's 240 degrees. Number 6. Negative 3 pi over 2. I'm going to take that times 180 over pi. Pi's cancel. Radians cancel. We're good. How many times does 2 go into 180? 90. So I'm going to cancel that out, giving me 90. Negative 3 times 90 is? Negative 270 degrees. Phil, how you doing over there? Are you like, man, it can't be this easy. It's going to be a trick here, right? Always waiting to move on, right? Number 7. I have pi over 6. To change that to degree mode, I'm going to multiply by 180. Technically over pi. My pi is cancel. What's 180 over 6 going to get me? 180 over 6? 30 degrees. And then I have number 8. 5 pi over 3. I'm going to take that times 180 over pi. My pi's cancel. 3 goes into 180 how many times? 60. 5 times 60 is? I get 300 degrees. Again, what do you recognize? Radians has pi. Degrees has no pi. Kind of difference in the two. Okay? All right. What?
They get cake instead of pie.
They get cake instead of pie. Take a couple seconds. Try these 4 on your own. Convert them from degrees to radians or from radians to degrees. Take a couple seconds. Try these. All right, so let's look at number 9 here. I have 60 degrees. I want to convert that to radians. So 60, 180. How many times is 60 going to 180? 3. So I get pi over 3. Number 10. Negative 2 pi over 5. I'm going to change that to degree mode. Pi's cancel. There's my radians. 5 goes into 180 how many times? 36. So I get negative 2 times 36 is? Negative 72 degrees. And then number 11. 5 pi over 6. To change it to degrees, I'm going to multiply by 180 over pi. Yeah. Pi is cancel. 6 goes into 180. 30 times. 5 times 30 is 150 degrees. And then number 12. To go 2 radians, I'm going to divide by, or multiply by, I guess, pi over 180. And cross off my zeros. 30 over 18 simplifies to, so I get 5 pi over 3. How's that? Not too bad? Pretty good? Good deal. All right. Here's the next part. The unit circle.
That's just great.
The unit circle shown on the right has a radius of 1 unit, so the terminal side of each angle has a length of 1 unit. Now, this is the unit circle used a lot of times in trig here. You will want to use this as a reference for everything we're doing here. Okay? Miss Fendel, I think, actually does have paper copies. If you need a paper copy, it'd be fine. All of this, okay, it's not that bad once you get the hang of it. What this is all based on, it's all based on right triangles. Okay, within respect to the coordinate plane. Okay, for example, we're having, degrees all the way around. Okay, so if I'm talking about 30 degrees, I'm talking about this right triangle right here. Okay, now what this comes from is the terminal side each has an angle with a length of 1 unit. So that means that is a length of 1 unit. This is a length of 1 unit. Everything has a length of 1 unit, making it a lot easier, and then it's simplified down technically. Okay, and again, you look at this and you're like, man, that's tough, it's confusing. It's not that bad when you look at it here. What's nice is, we talked about radians and degree already. Guess what? They give you both of them here. They give you 30 degrees and pi over 6. They're giving you the radian and degree mode. Great. All right. And again, the ordered pairs shows the length of each side of the triangle. Notice the ordered pairs for the points 0, 90, 180, 270. So at 0, it's just 1, 0. At 90, 0, 1. At 180 is negative 1, 0. And at 270 is 0, negative 1. Okay? And again, this all stems from the right triangle that makes with respect to the reference angle or the x-axis there. Here's what we're going to be focusing on today. We're going to be finding the trig functions for sine, cosine, and tangent of this. And already you're like, how are we going to even do that? It's not that bad. On the circle, for every value of theta. Now, theta, again, is our degree measures here. Okay? If I give you sine, we're looking sine right here. Sine is nothing more than your y value. Now, why is it your y value? Because what does sine represent? Sine is our opposite of our hypotenuse. So technically, if that is my angle there, my opposite side is square root of 2 over 2. My hypotenuse is 1. If I divide by 1, I end up with the same thing. Does everybody understand that? That's where this comes from. Okay? So anytime you have sine, it is always going to be your y value. That is important. Cosine. Cosine is then going to be my x value. Tangent is the tough one. Why is tangent tough? Because you actually have to use both values now. Tangent is y over x. Okay, now here's kind of unique. I'm going to look at this one up here. I think this is actually a 45-degree angle right here. Okay. Y over x. Let's look at this here. What is my y value there? My y value is square root of 2 over 2. Does everybody see that? I'm looking right here at this one. Okay. So I have the square root of 2 over 2. And I'm going to write that over technically my x value. What's my x value? Square root of 2 over 2. What's wrong with that? I have a fraction within a fraction. Can I technically have a fraction within a fraction? No. Can you divide fractions? No. What do you do instead of dividing fractions? Multiply by the reciprocal. So when I have this, so I'm going to take square root of 2 over 2. I'm going to multiply it by 2 over the square root of 2 to simplify it, basically. Now again, this just comes up there and it's the reciprocal. Now what happens in this one? My 2's cancel. What happens to my square root of 2's? What's my tangent here going to be? 1. My tangent there is 1. Tangent's the only one you really got to do some work on technically. And the only reason you got to do work on it is because you have to take your y value over your x value. Sine and cosine are just going to be your y or your x values. So you look at your unit circle like sine of 30 degrees. Well, that's going to be 1/2. I'm just looking right there for that y value, and that's going to be it. Okay, so you will want this unit circle to help you out on these. Okay, to do it without a unit circle is really rough. Okay, so let's look at a couple. I'm going to be referencing back and forth. Okay, so I'm going to go back and forth from the next page to this page, just so you know. So let's look at number, we're on 13, I think. When it comes up here, slowly but surely. All right, 12. Ooh, missed 12. Or did I repeat 12? I think I repeat 12. Find the exact value of each trigonometric function. Use the unit circle. I want the sine of 60 degrees. Okay, so sine of 60 degrees. Is everybody with me? Sine of 60 degrees. I'm going to go back. I'm looking for 60 degrees on the unit circle. 60 degrees is right here. Now I'm looking at sine. Sine is my what value? Sine is my y value. So my y value is square root of 3 over 2. So, number 12, the sine of 60 degrees is nothing more than the square root of 3 over 2. That's all it is. Okay, we're using the unit circle to find sine, cosine, tangent. Let's try number 13. Cosine of 5 pi over 3. 5 pi over 3. Well, let's go back to the unit circle. Let's find 5 pi over 3. How many degrees is 5 pi over 3? That is 300 degrees. So I'm looking right there. Ooh, that's a bad one. So I'm looking right here. And I want the cosine. Cosine means I want my what value? X. So x value is 1/2. So cosine of 5 pi over 3 is going to be, what's it going to be? 1/2. And then we get to tangent. Tangent's the tough one. I'll be honest. Tangent's tough. Tangent of 225 degrees. Okay, so let's go back. Find 225. As I find 225, I'm going to look about right there. Okay, 225. Now tangent is my what over my what here? Y over x. Okay, now you can't see it here, but my y, it's tough to see, I don't know, maybe you can tell. They are negatives up there. Does everybody see the negative values? Because these are technically on the coordinate plane. There is a negative value there and there. So just make sure you do recognize those negatives. Okay. As I look here, I want to put my y value over my x value. What is my y value going to be? Negative square root of 2 over 2, right? What is my y value? Over negative square root of 2 over 2. Does everybody see that? Can I have a fraction within a fraction? So I'm going to multiply by the reciprocal. My 2's cancel. My square roots cancel. A negative times a negative is a positive. And I'm going to get 1. So tangent's a little bit tougher because you actually do have to do some work there to simplify it. No. For 45 degrees it is, though. Technically, the reference angle on 225 is 45 degrees. So anytime you have a 45 degree angle, it would be 1. And that's what you, when you get really good at this, you start recognizing that. Okay, but yeah. Alright. So tangent's the tough one, I'll be honest. Let's try 15. The tangent of pi. Tangent of pi. Who remembers what pi is in radian form? Or pi is in degree form? Pi is how many degrees? How many? Yeah, pi is 180 degrees. So as I look right here, pi is 180. I want to find the tangent. What is my y value there? My y value is 0. What's my x value? 0 over negative 1 simplifies to 0. Tangent of pi is going to be 0. Okay. Does everybody go to sine and cosine at least? Tangent's the one that you got to do some work on. Okay. Let's go back. Write down number 16, 17, 18. I want you to try those 3 on your own. Okay, write down 16, 17, 18. I'll go back to the unit circle so you can give it a shot there. So 16, 17, 18, you want the sine of 330, the cosine of 150, and the tangent of 240. Okay. Everybody got them written down? All right, here is the unit circle. Take a couple seconds now and try those 3. Find sine, cosine, tangent of those degrees and radians. So I think it was, I don't know what number was it, 17, something like that. Sine of 330. The sine of 330. If I look here at 330, now sine is reference to my y value. The sine of 330 is going to be what, Sean? It is negative 1/2. Nice job. And do make sure you put in the negative value there. Good work. Cosine of 150. If I look for the cosine of 150 there, what is my cosine of 150 going to be, Andy? negative square root of 3 over 2. And then I have tangent of 240. Now, tangent of 240 here, as I look at this, what is my y value? My y value is negative square root of 3 over 2. Over, what's my x value? Negative 1/2. Can't have a fraction within a fraction, so I multiply by the reciprocal, giving me negative square root of 3 over 2 times negative 2 over 1. And when I simplify that, I'm going to get an answer of what, Maddie? Ooh, so close. It's actually positive square root of 3. Because your negative times negative gets you a positive. So that one's just going to be just the square root of 3. Because your 2's cancel. You end up getting square root of 3 over 1, which is just the square root of 3. All right. Nice job.
What's the answer on that?
On the last one there?
Yeah.
Square root of 3. So your tangent ones, you'd have to actually do some work on. It would be positive because they're both going to be negative. And you might not be able to tell if they're both negatives up there. It's a little tough, I know, on the reference circles. But those are both negatives. So you get negative divided by negative. There's your assignment. You have the bottom assignment.